Hello, we're looking at a ton of information with the goal of creating a piecewise defined function to capture this information. So starting at the very top, the retrovirus HIV can be transmitted from a mother to a child during breastfeeding. But under conditions of poverty or poor hygiene, the alternative to breastfeeding carries its own risks for infant mortality. These risks differ in that the risk of HIV transmission is the same regardless of the age of the child, whereas the risk of mortality due to artificial feeding is high for newborns but decreases with the age of the child. So for the purposes of this problem, we are going to assume that the additional risk of death for artificial feeding has the formula that is given here. We can see that this is an exponential decay function, and so that this would decrease with the child's age. And then the additional risk of breastfeeding is this function, and this is constant, which is what is described in that first paragraph. And t in our exponential function is the child's age in months. We are to create a graph of the additional risks for the first year of the child's life, so I'm going to go to my graphing calculator in order to do that. In my graphing calculator, I went to y equals, and I typed in both of these formulas. So y1 is that exponential decay function, y2 is the additional risk of breastfeeding. I went to my window. It told me to use the first year of life, so 0 to 12 months, and with exponential decay we saw the starting value of 5 and it decreased from there. So I am ready to graph. This blue curve is the curve that describes the risk of artificial feeding. So this would be like formula given via a bottle. And then this red line is the risk of breastfeeding. And so the first question that we are asked is, at what age is the additional risk of HIV transmission from breastfeeding the same as the additional risk from artificial feeding? So I can see that they are the same right here where they intersect, and I'm going to use my calculator to find that. So second, trace, intersect, first curve, second curve, and it appears to be happening right over here, so we guess, and we get at 3.79 months. The risks are both 2. So going back to our PowerPoint, we're to create the graph, so let's take a moment and sketch out that graph. So this is months, and that went 0 to 12. This is risk, and it doesn't really tell us how risk is measured, but we started at 5, and so we had the risk coming down like this, and this is for this A formula, artificial feeding. And then we had the risk coming across here like this, and that is the risk of breastfeeding. We just found the point where these two, the point where these two are the same. So it says at what age, so right here, at what age is the additional risk of HIV transmission from breastfeeding the same as artificial feeding? And we found that that was at 3.79 months. So then it asks us, for which ages of the child does breastfeeding carry the smaller risk? So I have to look at which line is which. So here's breastfeeding straight across, and breastfeeding has a smaller risk here at the beginning because it is actually below the artificial feeding risk line. So the ages would be from birth up to 3.79 months. At 3.79 months, we saw that was this point where they met and they were the same. Then it asked me, what would the optimal feeding plan be for a child to minimize the additional risk? So that would mean that we would have the child be breastfed from birth to 3.79 months. And then artificially fed. So looking at this, that means for the first 3.79 months, they would be using the breastfeeding, and they would have this additional risk that is constant at 2. And then at 3.79 months, they would switch to bottle feeding with formula, so that's artificial feeding, and their risk would decrease from that point along this curve. So now we are to write a piecewise defined function that models this optimal plan. So to write a piecewise defined function, we start out with r, the risk, and we put our equal sign, and then we put a brace here. And so there are two different formulas in here because there are two different formulas as part of this problem. So the risk that are optimal at the beginning of the child's life here are constant at 2. And that is what we are supposed to use from birth, so from 0 up until 3.79 months. So that means our t, our time values, which were in months, starting at 0 up to 3.79. After that initial time right here, then we want the child to be artificially fed. And so from that time forward, we want to use this formula. So we're going to have 5 times 0.785 to the t power. And we're using this formula anytime that the time is greater than the 3.79. So we have these two range of values telling us which formula to use when. So then it asks us, what are the additional risks for a 6-month-old who is fed on the optimal plan? So when I think about a 6-month-old, that is obviously not in this first range. So the 6-month-old should be on the artificial feeding plan, and I should put the 6 in here because that is a time that's greater than 3.79 months. So I'm going to go out to my calculator and do that. So in my calculator, I type in my formula, so 5 times the 0.785 to the 6 months. And so we get additional risk of 1.17. So what is the additional risk? The risk is 1.17. And it never told us in this problem how risk is measured, so I don't really have like a label on that. So point of this problem is to create this piecewise defined function, and that is when you are using different formulas to model different parts of the function. And we do have to tell our reader when to use that formula by giving a range of values for when the formula is valid.